Okay, so this is all a bit abstract maybe, so let's just write an example right below. So if you're trying to find, say, A1, 1, 2, 3, plus A2, minus 1, 0, 6, plus A3, 1, 1, 1, is equal to 2, 2, 7. Why not? Okay, that is logically equivalent to solving this system here. 1, 2, 3, negative 1, 0, 6, 1, 1, 1, 2, 2, 7. Okay, so this gives us an option. Okay, we can either work to find a solution here, or more likely, we can work to find a solution here. All right, some more examples. So how about some geometry rather? Okay, in R2, so if I have a vector, say u, what does the span of u, what does that look like? Well, span is the set of all linear combinations. Span is the set of all linear combinations. Span is the set of all linear combinations of u, just the vector u. So in here you have 2u, 3u, minus 4u, half u, and so on and so forth. So let's go baby sky blue. So 2u would look something like this. 2u would be like this vector, right? 2u's in there. Oh, stop scrolling. 3u would be something like this. A half u would be like this. If you start getting negative, you get negative u. Is this, what is this? Is a u. 3u, half u, negative u, negative 2u. Okay, but I have everything, right? I have a half u, I got quarter u, I got 3/4 u. So I hope you can convince yourself that you have, well, you can visualize it as the line, right? So that's what we'll write down here. Span of u is equal to line, we'll say the line, through the origin, 0 vector, right like that, through 0, and u. Okay, so you get this whole line here. Okay, not so thick, but you can get the idea. Okay, if you haven't copied, you pause now and copy that. Okay. What if we have two vectors? So say u goes like this, and say v goes like this. What is the span of u and v? Well, it contains things like 2u plus just v, right? U plus 2v. Say minus 2u minus v. So what do these things look like? Okay, so if I do 2u plus v, what happens? You get 2u would be about here. And then you add v to come down to about here. Oh, that's not a straight line at all. Too much coffee. 2u plus v. And then if you add u plus 2v, you go u plus 2v. That's 1v, and 2v is roughly here. So a vector ending at that point. Okay, whoa. What did I say? U plus 2v. So I end up in two very different places, right? Okay, here's a question you should ask yourself. Is there any point in the xy plane that I cannot get to with a linear combination of u and v? So imagine all these points. I can in fact get to any of them, right? Just by choosing the right linear combination. If I wanted to get to, say, this point here, I could have some multiple of u, right? Would bring me, say, down here. And then some multiple of v. No, I have to say AU plus BV. Okay, I could get there, right? So hopefully all this convinces you that the span of U and V, in this case, is absolutely everything. It's all of R2.